Right now, the ground beneath one small corner of Yellowstone National Park has blown apart twice in less than 2 years. And the second time it happened, scientists actually caught it in the act. In July of 2024, a hydrothermal explosion tore through Biscuit Basin, throwing rock and scalding water hundreds of feet into the air and destroying a boardwalk, with tourists running for their lives and, remarkably, nobody hurt. Then, in June of this year, the exact same general spot did it again. This time in the dark hours before dawn, caught not by a tourist's phone camera but by a brand new network of scientific sensors installed specifically because of what happened there the first time. This is the story of Yellowstone's Biscuit Basin, why the same patch of ground erupted twice in 3 years, what scientists are actually saying about the odds of it happening again, and why this, not a supervolcano eruption, is the hazard. Geologists at Yellowstone genuinely worry about most. No hype, no exaggeration, just what actually happened and what the data behind it means. Drop a comment and tell me if you have ever visited Yellowstone and whether you walked anywhere near Biscuit Basin, because I read every one of these. If you want grounded science coverage instead of panic headlines, subscribe. It is free. And a like helps this reach people who need to understand this before their next trip out. West. Let us go for 5,000 likes on this one. Thank you. Now let us get into it. To understand what just happened this summer, you have to start with the first explosion, because it set up almost everything that followed. Shortly before 10 in the morning on the 23rd of July, 2024, an explosion of hot water, mud, and rock tore out of Black Diamond Pool in Biscuit Basin, a popular thermal area located less than 2 miles northwest of Old Faithful. According to the United States Geological Survey, no monitoring instruments detected any precursor activity beforehand, meaning the explosion gave essentially no warning at all. Videos posted to social media showed a plume of water and rock fragments rising an estimated 400 to 600 feet into the air as visitors ran for safety. The explosion heavily damaged the nearby boardwalk, and remarkably, despite happening in one of the most heavily visited areas of the entire park, nobody was injured. Geologists who later examined the debris found something specific and telling. The rocks thrown out by the blast were made OF glacial material, sandstone, siltstone, and gravel, the layers that sit immediately beneath the thin silica crust covering the ground, rather than the solid rhyolite bedrock that sits roughly 175 feet further down. That detail told scientists the explosion originated at a genuinely shallow depth, in the loose, water-saturated layers just beneath the surface, rather than anywhere near the deep volcanic plumbing that powers Yellowstone's supervolcano system, an important distinction we will come back to. Because that 2024 event happened with zero warning, the Yellowstone Volcano Observatory made a specific decision afterward. They installed new geophysical monitoring equipment directly at Biscuit Basin, instruments capable of detecting the seismic energy and low-frequency sound waves, called infrasound, that typically accompany pressure changes underground, even when nothing is visibly happening at the surface yet. That decision fit directly into a broader monitoring plan the observatory had already laid out back in 2022, which specifically named expanding hydrothermal, monitoring as a priority goal for addressing exactly this kind of small but genuinely hazardous event. The first piece of that expanded network, installed at Norris Geyser Basin in September of 2023, was followed by the additional sensors placed at Biscuit Basin after the 2024 explosion, and that decision turned out to matter almost immediately. Just after 5 in the morning on Saturday, the 13th of June this year, that new equipment registered exactly the kind of signal it had been installed to catch. Seismic energy paired with an infrasound signature coming from the direction of Black Diamond Pool. A research camera installed at the site actually recorded the moment itself, showing a dark steam plume beginning to jet from the ground at around 9:50 in the morning. MDT, a few tens of meters, a few dozen yards north of Black Diamond Pool. Unlike 2024, this explosion was notably smaller, but it left its own distinct mark on the landscape. A fissure roughly 18.5 meters, about 61 feet long, opened up in the ground, filled with near-boiling water. Park interpretive staff noticed something else that day too, starting from Biscuit Basin and running all the way downstream to Midwag. A geyser basin, a distance of roughly 6 kilometers, or about 3.5 miles, the Firehole River had turned a light gray, milky color, carrying sediment that had been kicked up by the explosion far downstream from where it actually happened. 2 new runoff channels carrying that sediment into the river were visible directly from the road throughout the day. Within days, a new thermal feature had formed near the site, a pool of near-boiling water that had not existed before the explosion opened up the ground to create it. Here's the part of this story that matters most, and it is a genuinely encouraging one headline. The 2024 explosion happened with absolutely no detected precursor activity. The 2026 explosion at the same general location was captured in real time by instruments installed specifically in response to the first event, registering seismic and acoustic signals as the explosion began, even though this particular event turned out to be too fast-standing. D too small for that warning to translate into advance notice for anyone standing nearby. That distinction, zero detection in 2024 versus real-time detection in 2026, is exactly the kind of validation the Yellowstone Volcano Observatory was hoping the new monitoring investment would eventually provide. Proof that the sensors installed after the first explosion are actually capable of catching this category of event as it happens, rather than only being useful after the fact. Now let us get into the actual mechanism driving this, because a hydrothermal explosion works fundamentally differently from the kind of volcanic eruption most people picture when they hear the word Yellowstone. According to the Yellowstone Volcano Observatory, hydrothermal explosions are violent, dramatic events resulting from the rapid ejection of boiling water, steam, mud, and rock fragments, triggered by sudden pressure changes that cause liquid water trapped underground to flash almost instantly into steam. This is not molten rock forcing its way to the surface, the mechanism behind an actual volcanic eruption. It is superheated water, sitting in shallow underground reservoirs at a temperature and pressure that keeps it liquid, suddenly losing that pressure balance, whether from a shift in the rock above it, a change in groundwater flow, or some other disturbance, and converting to steam almost instantaneously. Steam takes up dramatically more volume than liquid water, and that sudden, violent expansion is what blasts rock, mud, and boiling water outward with enough H-force to destroy a boardwalk and send a plume hundreds of feet into the air. It is, in a very real sense, the same basic hot water plumbing system responsible for every hot spring, geyser, and fumarole in the park, just failing catastrophically all at once instead of venting gradually and predictably the way Old Faithful does every day. This is also why USGS geophysicist Michael Poland, scientist in charge of the Yellowstone Volcano Observatory, and other scientists who study the park consistently point to hydrothermal explosions, not supervolcano eruptions, as the hazard actually worth paying attention to at Yellowstone. Scientists evaluate natural hazards by weighing both how often events happen and how severe they tend to be, and by that measure, the numbers are not close. Yellowstone has experienced zero lava flows or volcanic eruptions of any kind in the past 70,000 years, and only 3 caldera-forming supereruptions in its entire multi-million-year history. Events so rare they fall well outside any human timescale worth planning around. Damaging hydrothermal explosions, by direct contrast, can occur several times a century. Researchers studying sediment cores pulled from the floor of Yellowstone Lake have identified at least 16 distinct hydrothermal explosion deposits laid down over the past 14,000 years, and at least 20 large hydrothermal explosion craters, meaning craters wider than 100 meters, have been mapped across the park in total, a scale of repeated activity that dwarfs anything seen in comparable geothermal areas anywhere else on Earth. The largest of those events puts the 2024 and 2026 Biscuit Basin explosions in genuine perspective. Roughly 13,800 years ago, an explosion at Mary Bay, along the northern edge of Yellowstone Lake, blasted out a crater 2.5 kilometers, about 1.5 miles wide, the largest hydrothermal explosion crater ever documented anywhere on Earth. Geologist Lisa Morgan, who has spent decades studying the lake floor, has estimated that event ejected roughly 1/4 of a cubic kilometer of mud, sand, and water-saturated rock, a scale almost impossible to compare to a boardwalk getting damaged in Biscuit Basin. Researchers believe Mary Bay was triggered by a sudden earthquake-driven drop in lake level that abruptly changed the pressure sitting on top of the hydrothermal system underneath it, allowing trapped water to fall ash to steam all at once. A separate large crater nearby, known as Elliott's Crater, appears to have formed roughly 8,000 years ago when a major earthquake directly ruptured an underground hydrothermal dome. Based on the rate at which large crater-forming explosions have occurred over the past 16,000 years, the USGS estimates that an explosion large enough to blast out a crater 100 meters, or about 328 feet wide, might be expected roughly once every 700 years, somewhere in the park. Smaller events, the size of what just happened twice at Biscuit Basin, are a completely different story, and this is worth being clear about rather than treating every hydrothermal event as equally alarming. Minoar hydrothermal explosions are genuinely common across Yellowstone. A similar explosion struck Biscuit Basin itself back in 2009, well before either of the two recent events. A minor explosion also occurred at Norris Geyser Basin, where the park's very first dedicated hydrothermal monitoring equipment was installed back in September of 2023. Porkchop Geyser, also in Norris Geyser Basin, produced a notable explosion back in 1989 that left a visible 15-foot wide apron of rock debris still present today. In the 1880s and early 1890s, Excelsior Geyser in the Midway Geyser Basin produced a whole series of powerful explosions and eruptions, some hurling rocks as far as 50 feet. None of this means Biscuit Basin is uniquely unstable, or that something unprecedented is building underneath it specifically. It means this is simply how Yellowstone's hydrothermal system behaves, repeatedly in scattered locations, on a timescale of years and decades rather than millennia. Precisely the pattern the park's geologists have been documenting and expanding monitoring for since well before the 2024 explosion made international headlines. So, what does this actually mean for you, particularly if a trip to Yellowstone is anywhere in your future? It means treating boardwalk closures and posted thermal area warnings as genuinely serious rather than as overly cautious park bureaucracy, since the geologic record makes clear that any given thermal feature, not just the famous ones, carries some baseline chance of a violent, sudden explosion with essentially no warning. Exactly what happened in 2024. It means understanding that the new monitoring equipment installed at Biscuit Basin and the broader push to expand similar sensors across other thermal areas like Norris is a genuine, meaningful upgrade in the park's ability to detect this activity as it happens, even though the June explosion showed that detection does not always translate into enough lead time to warn anyone standing nearby before a smaller event occurs. And it means keeping the actual hazard hierarchy straight, hydrothermal explosions happening on a scale of years to decades against a supervolcano eruption that has not happened in Yellowstone in hundreds of thousands of years and shows no signs of changing that pattern anytime soon. The honest, grounded summary is this. Biscuit Basin experienced a significant hydrothermal explosion in July of 2024, with no precursor activity detected beforehand, followed by a second, smaller explosion at the same general location in June of this year, this time captured directly by monitoring equipment installed specifically because of what happened the first time. The mechanism behind both events is the same one responsible for every hot spring and geyser in the park, shallow, superheated water, suddenly flashing to steam when the pressure holding it in check shifts. Damaging hydrothermal explosions of this scale occur several times a century across Yellowstone as a whole, a genuinely common hazard by geologic standards, while explosions large enough to carve out craters more than 100 meters wide, the scale of the ancient Mary Bay event that remains the largest EVE-R documented on Earth, occur roughly once every 700 years. Scientists at the Yellowstone Volcano Observatory continue to expand monitoring specifically because OF events like this one and the June explosion stands as the first real evidence that the equipment installed after 2024 is capable of catching this category of event as it unfolds. We are going to keep tracking this as monitoring data continues to come in, sourced the same way we did today, straight from the United States Geological Survey, the Yellowstone Volcano Observatory, and the geologists actually studying the system, not recycled headlines. Subscribe so you do not miss the next update, because based on everything we just walked through, this almost certainly will not be the last hydrothermal explosion Yellowstone produces. And leave that comment below. Tell me if you have ever walked past Biscuit Basin yourself, because behind every one of these numbers is a visitor who ran from falling rock and boiling water in 2024 and walked away unhurt. A park geologist reviewing sensor data at 5 in the morning this June as a new fissure tore open in the dark. And a lakebed that has been quietly recording this exact same story over and over for the past 14,000 years. 5,000 likes on this one. Let us go. See you in the next one.